We present Refraction, a new puzzle game that allows elementary school students to experiment with and learn about fractions. The goal of this game is to present fractions in a fun environment that students will naturally gravitate towards. The game mechanics are not obviously a lesson in fractions, but require knowledge of fractions to succeed. We have developed this game in cooperation with experts in game design, learning, early math education, and virtual manipulatives. In Refraction, the player must provide help to animals whose spaceships have lost power and gotten stuck in space. The player can help them by redirecting lasers. Each spaceship requires exactly the right amount of power, which is a fraction of the whole laser. This fraction is indicated by the yellow number on the spaceship. In order to redirect the laser to the target, we need to use this bender to bend the laser. The laser is now reaching the spaceship. However, this spaceship wants only 1/2 of the laser, and we are supplying it with a whole laser. We can split the laser using either the 2-splitter or the 3-splitter. Lasers are colored based on their denominator. If we use the 3-splitter, the laser pieces will all be colored blue because their denominator is 3. If we try to power the spaceship with this piece, the spaceship will only get 1/3, which is too low. If we use the 2-splitter, on the other hand, the amount is correct. When all of the spaceships have been satisfied, the player will complete the level and receive a victory animation showing the size of the laser at each point in the level. In this version of the game, we have enabled players to jump ahead by clicking on options in the main menu and clicking Jump to 7-7 as shown. The player can then use the level selection screen to access all of the levels in the game. There are currently about 60 levels in the game, which are used to teach unit fractions, equal partitioning, addition, multiplication, finding common denominators, mixed numbers, and improper fractions. Refraction is an active research project, and we plan to add more content in the near future. Since fractions of the laser are manipulatable objects within the game, the player naturally learns the multiplicative relationships between the quantities. Satisfying the spaceships with the correct amount of the laser requires the player to plan ahead and think about how to divide the laser. The player can combine splitters to produce even smaller fractions. Since dividing a laser by a whole number is the same as multiplying by a fraction, early levels of the game implicitly teach simple fraction multiplication. We give the users a magnifying glass to help them understand more about the fractional quantities of the lasers. When the user clicks on the laser, it will bring up an expanded view, allowing the player to see the relationship between the width of a particular laser fraction and a whole laser. This helps reinforce the continuous model of partitioning lasers that underlies the game. Lasers are also animated with moving particles that become less frequent as a laser fraction gets smaller. This provides an additional model of fractions, which in this case is discrete. This level requires the player to create 1/6 and 1/9 from a single laser, as shown. The levels in the middle of the game, such as this one, require the player to create more complicated unit fractions by splitting the same laser multiple times. Players can also add lasers using these combiner pieces that will add together the lasers that are directed into them. However, lasers cannot be combined with a combiner unless their colors match. Since colors are determined by fraction denominators, this forces the player to think about splicing lasers into the right partitions in order to combine them, and also allows us to teach the player how to find common denominators. In this level, in order to give the spaceship 5/6 of the laser, the player must use expansion pieces to convert the fractions. The expansion piece with 2 tubes multiplies the fraction by 2/2, and the piece with 3 tubes multiplies the fraction by 3/3. To solve the level, the player must convert 1/2 to 3/6, and 1/3 to 2/6 before adding them to create 5/6. This level is an example of how our game can teach how to add proper fractions to produce a result greater than 1 whole. This level can be completed 2 ways. In one, the user creates 2/3 and 1/2 and then adds them to create 7/6 as shown. In the other, however, the user just adds 1 to 1/6 to produce the same result. While the game allows players to experiment and discover both solutions on their own, by varying the pieces we can force the player to discover both solutions. We can extend this upwards to teach more complicated mixed numbers and improper fractions. In this level, the player can discover that 5/2 is the same as 2 complete wholes and 1/2. The game mechanics behind Refraction can be scaled to create very complex levels such as this one. If children master basic concepts and are willing to go further and undertake greater challenges, the game can increase difficulty to accommodate them. This level, which appears near the end of the game, is quite difficult and requires the player to integrate all of the concepts that he or she has learned so far. Refraction records everything the player does so that it can be played back later. This data can be used both to refine the game and to evaluate whether a child has learned the relevant fractions material. Eventually, we hope to be able to use this data to tailor the game to each student specifically, and this is an area of future work. We also plan to use this data to evaluate the effectiveness of various proposed approaches to teaching fractions, and allow the game to be used as a testbed for educational researchers to test new theories. We want to involve teachers and parents in the game as much as possible. We currently do this in two key ways. First, we provide a level editor that allows users to create their own fractions problems within the game. Teachers can use this editor to create levels for their students, and children can create challenges for one another. The editor allows players to use any of the pieces in the game to make a level, and then gives them a chance to test it out. Here are some examples of levels that players have made. The second way that we involve teachers is by providing the ability to generate levels automatically from mathematical expressions. A teacher can enter an expression in this interface, such as 1/2 plus 1/4, and the game will automatically create a level that requires the player to solve that expression. Note that this is the simplest level you can imagine for this expression. Since children vary widely in terms of ability and interest in video games, we can increase game difficulty independently of mathematical difficulty. If the teacher increases the difficulty using these slider bars, the generator will create a level that has exactly the same math as before, but is now much more difficult. This allows a teacher to give the same math problem to students with different skill levels and adapt the game to individual students. The generator can create literally millions of different levels with the same parameters. A teacher can also increase the mathematical difficulty of the level by entering additional expressions. The generator will combine these expressions into one big level for the student to solve. Pilot studies, in which hundreds of students played Refraction, have shown that children are able to learn how to play the game, and that they make fewer wrong moves as they get further into the game, even as the math problems are getting more difficult. We asked kids in our pilot studies if they wanted to play more of the game afterwards, and on a scale of 1 to 5, 5 being the highest, the average response was 3.8. In order to determine whether the skills learned in the game transfer to traditional pen and paper fractions problems, we have made agreements to deploy Refraction to 10,000 students over the next 2 years through K-12, which is a company that operates many online public schools, and other traditional public schools in the United States. Although Refraction was designed to teach fractions to elementary school students, we discovered that the game is actually pretty fun for adults as well. We released the game on Kongregate, which is one of the most popular flash game websites in the United States. Refraction was so well received by the Kongregate community that they put us on the front page for a short time. Refraction has been played over 400,000 times on Kongregate and is currently rated 3.78 out of 5, which is really high for an educational game. We believe that this is evidence that Refraction's game design creates a truly engaging experience for players of all ages, and that Refraction is just as deep and as complex as any other modern game.